Hi all, welcome to new class. Today's class is about gated latches. So latches are flip-flops. So there are mainly two types of flip-flops: asynchronous flip-flops and synchronous flip-flops. So asynchronous flip-flops means these are non-clocked flip-flops, and synchronous flip-flop means these are clocked flip-flops or gated flip-flops. So in asynchronous flip-flops, the output can change state anytime the input conditions are changed. So these are called asynchronous flip-flops or asynchronous latches. And in a gated flip-flop requires an enable input. Enable input. So it requires an enable input. So enable input means it need a clock input. That is, it need a clock signal to enable the latch. So these types of flip-flops are also called level triggered flip-flops, because this type of flip-flop respond to the changes in inputs only as long as the clock is high. So these are called level triggered flip-flops. And also there are positive level triggered flip-flop and negative level triggered flip-flop. And also there are edge triggered flip-flop. Depending upon the edge of the clock, that is depending upon the positive edge of the clock. Suppose this is a clock signal, so this is called the positive edge of the clock, and this is the negative edge of the clock. So depending upon the positive edge of the clock and negative edge of the clock, edge triggered flip-flops are also positive edge triggered flip-flop and negative edge triggered flip-flop. The gated SR latch. A gated SR latch requires an enable input. Its S and R inputs will control the state of the flip-flop only when the enable is high. When enable is low, the input becomes ineffective and no change of the state can take place. So the enable input may be a clock. So a gated SR latch is also called clocked SR latch or synchronous SR latch. And this is the logic diagram of the gated SR latch, and this is logic symbol. This is logic diagram and this is logic symbol, and this is the truth table of the gated SR latch. So here these are the inputs 0 0. So when the enable is high, the inputs SR 0 0 means the output is Q0, that is no change. And when SR is 0 and 1, the output is 0, that is reset. Then When S and R are 1 and 0, then Q is 1, and when S and R are 1, then the output is invalid. So for example, initially Q is set, that is Q is equal to 1 and Q bar equal to 0. Then assume S equal to 0 and R equal to 1, and enable is high. So when S equal to 0, R equal to 1 and Q equal to 1 and Q bar equal to 0, enable is high. So here it is 1 and 1. 1, 1 to this NAND gate means, so the output is 0. Then here this is bubbled OR gate. That means this is also a NAND gate. Bubbled OR gate is also a NAND gate. So here the inputs are 0 and Q is 1. 1 and 0 here. So the output is Q bar now becomes 1. 1 and 0 to this bubbled OR gate or NAND gate means the output Q bar is equal to 1. Then here S is 0 and enable is 1. 0 and 1 to this NAND gate means the output is a 1. And here the inputs are Q bar is now 1. 1 and 1 to this bubbled OR gate means the output is 0. So Q becomes 0. That is when inputs are S equal to 0 and R equal to 1, the output is reset. That is R is here 1. So that means the output is reset. That is Q is equal to 0. Next is the gated D latch. D means data or delay. So in the case of SR latch, when S equal to R equal to 0 and S equal to R equal to 1, the other input combinations are 0, 1 and 1, 0. That is, S and R are always the complement of each other. So we can construct a latch with a single input and obtain the R input by inverting it. That is, this is the single input and R is obtained by inverting it. And this single input is labeled as D, that is data. And hence the device is called a D latch. And it differs from the SR latch is that it has only one input in addition to the enable input. And here when D is equal to 1, then what happens? So this is SR latch. So when D is equal to 1, then we will have S equal to 1, and here this R is equal to 0. So the output will be high, that is it is set when enable is high and D is equal to 1. That means this is S and R latch. So the output is set, that is here the output is high 1. And when D is equal to 0, that means here S is equal to 0 and here R is equal to 1 and enable is made high, then the output is reset, that is Q will be 0. So that is the case of D input, D latch. So this is D. Input is D here. And when enable is low, the latch is ineffective and any change in the value of D input does not affect the output at all. Let us do a problem. Determine the output waveform Q for the inputs shown. The SR latch was initially set. So when the SR latch is initially set and here the enable is given and we have to find the output Q. Given that the SR latch was initially set. Set means initially Q equal to 1. So here first the enable is low. Low means it is in the output is in the previous state. That is output is high up to this enable low, and when enable is high, that means it will depend upon the inputs, that is S and R. So here this is high in this point. So in this point S is 0 and R is high. 0 and 1 at this point. 0 and 1 at this point means the output will be 0. So output will be 0 at this point because here this is 0 and 1, that is output is reset, and it will continue up to the next enable input. So here this enable input is up to this point, and in this point also the inputs are 0 and 1. So the output at this point also 0. And next is the enable is low. That means in the previous state up to the next enable input. So next enable input is this one. So at this point the inputs are 1 and 0. So here the inputs are 1 and 0. That means the output will be 1, that is set. That is 1 here. And here this point also, in this point also the inputs are 1 and 0. So here also this is 1, and here when the enable input is low, it is in the previous state. So up to this point the output is high. So next enable high is at this point. So at this point the inputs are 0 and 1. 0 and 1 means the output is 0, that is reset, and this is high. So here, but here the inputs are changing. So next the inputs changing at this point, that is here. At this point the inputs are 1 and 0. 1 and 0 means the output will be high when enable is high. That is here it will be high, that is 1. And again at this point the inputs are changing, that is 0 and 1 here, and also the enable is high. That means 0 and 1 means the output is 0. So this will be the output waveform for this input waveforms. Let us do another problem. Determine Q output waveform when the D latch was initially reset. So this is the input given. So we have to find the output waveform. So initially the latch was reset. So Q is equal to 0. So initially Q equal to 0. And here D is 0 here, but enable is 0. Then here 1, enable is 0. That means the Q is 0 here. And here 0, but enable is low. And here D is 1 at this point. So at this point D is 1 and enable is 1. So D equal to 1 and enable equal to 1 means the output is high at this point. And at this point also D equal to 1 and enable equal to 1. So here also up to this point it is high. Then here D equal to 0. D equal to 0 and enable is high. That means when D equal to 0 and enable is 1, output is 0. Output is 0 at this point. And here also up to this point D is 0 and enable is high. That means up to this point the output is 0 and here D becomes high and enable is also high. So this waveform we will get here. And here also up to this point enable is high and D is 0. That means the output is 0 up to here. And at this point the D is high. So and enable is also high and here it will become high. And here enable is low at this point, but D is high. That means it will be in the previous state. So it will be in the previous state, and when it becomes, that is here at this point, so here also enable is low. So when enable is high, next transition take place. So it will be high up to this point. And at this point, that is when enable is high, D is 0. That means the output will be 0. So up to this point, that is here also, at this point also D is 0. That means the output is 0 here. So here also it is 0. And here the enable is low. That means in the previous state. So in the previous state up to this point, next enable high. So next enable high is at this point. So up to that point it is in the previous state. When enable is high, so here is enable is high. That means the D is high in this point. So the output is high at this point. So at this point also the D input is high and it will continue up to next enable high input. that is up to this point it will be high, and at this point enable is high, that is the D input is 0. So at this point the output is 0 again. So in this way we will get the output. So check both the enable input and the inputs, whether it is D or S and R inputs, and according to that we have to draw the output waveform. Thank you for watching the class. If you like the classes, please like, share with your friends and subscribe my channel.